How good at math are you? I've put together a quick 1 or 2 question test for each grade level, from grade 1 all the way up to university level math. For each grade, pause the video, try the question, and then watch to see if you got it right. Make sure to leave a comment about what grade level you could get up to. Welcome to grade 1. To pass this grade, you just have to move the cupcakes to the correct section of the Venn diagram. The sections of the Venn diagram are sprinkles and chocolate icing. My first cupcake has sprinkles but not chocolate icing, so that will go here. My second cupcake has chocolate icing but not sprinkles. This cupcake has both chocolate icing and sprinkles, so that will go in the overlap of the two circles. And the last cupcake has sprinkles but not chocolate icing. If you got all the cupcakes in the correct section, congratulations, you passed grade 1. Welcome to grade 2 math. To pass this grade, you have to be able to tell time and add 2-digit numbers without a calculator. Let's start by figuring out what time the clock says. The hour hand is between the 3 and the 4, so I know it is 3 something. I'll figure out the minutes by looking at the minute hand, which is pointing at the 8. And remember, the big numbers represent increments of 5 minutes. 8 times 5 is 40, so I know the time is 3:40. Let's move on to the addition. I need to do 13 plus 28 without a calculator. I'll start by rewriting the 13 and the 28 into its tens and its ones. 13 is 10 plus 3, and 28 is 20 plus 8. I'll regroup those. I know 3 plus 8 is 11. 11 is 10 plus 1. And now the addition is easy. 10 plus 20 plus 10 is 40, plus 1 more is 41. If you're able to get those two answers, congratulations, you passed grade 2 math. Welcome to grade 3. To pass this grade, you're going to have to know stuff about fractions and know how to multiply without a calculator. Let's look at question 1 first. It says to color, then write a greater than, less than, or equal to symbol between the fractions. So let's look at our first two fractions. Let me color in 2/5 of the first circle and 1/2 of the second circle. I can see that 2/5 is less than 1/2, so I'll write the less than symbol between those two fractions. 2/5 is less than 1/2. Let's look at the next set of fractions. I'll shade in 5/6 of the first circle and 3/4 of the second circle. I can see that 5/6 is bigger than 3/4. So I'll write the greater than symbol between those two fractions. Let's move on to the multiplication question. Question 2 says evaluate 3 times 4 by representing with an array, and no calculator allowed. 3 times 4 just means 3 groups of 4, so I'll make 3 rows of 4. And now if I skip count by 4s, I can see that I have 4, 8, 12 dots in total. So 3 times 4 is 12. If you were able to get these 3 answers, congratulations, you passed grade 3 math. Welcome to grade 4 math. To pass this grade, we're going to have to calculate mean, median, and mode, and also do a subtraction with no calculator. Let's start with question 1. Before I try and calculate mean, median, and mode, I'm going to rewrite that data set in ascending order. Now that they're in proper order, I'm going to start by calculating the mean, which is just the average of these numbers. I can find the average by adding them all up and dividing by how many numbers I have. So I'll start by adding them all together and then divide by how many numbers I have. There are 12 numbers in this data set. When adding all the numbers together, it equals 24, and 24 divided by 12 is 2. So the average number of pets somebody has from this data set is 2. Let's now calculate the median. The median is just the middlemost number. Because there are 12 pieces of data, there is no one number that is in the middle of this data set. Between the 6th and the 7th number would be the middle. That would leave 6 pieces of data to the left and 6 to the right. So what's between the 6th and the 7th data set? Well, what's between 1 and 1? The average of 1 and 1 is 1, so the median is 1. The last thing we have to do is calculate the mode, which is just the number that occurs the most frequently. There are 3 zeros, but there are 4 ones. So it looks like 1 is the number that occurs the most frequently, so 1 is the mode. Let's move on to question number 2. I need to evaluate 970 minus 248 without a calculator. Let me set up the question, and now I'll subtract each column. I'll start with the ones column. I can't subtract 8 from 0, so I'll need to borrow from the 7, making it a 6, and that would make the 0 a 10. 10 minus 8 is 2, 6 minus 4 is 2, and 9 minus 2 is 7. If you were able to get these 4 answers, congratulations, you passed grade 4 math. Welcome to grade 5 math. To pass this grade, you're going to have to be able to do a division with no calculator and a multiplication with no calculator. Let's start with the division. Let me set up the division table. I'll start by seeing how many times does 12 go into 18. It can fit in one whole time. 1 times 12 is 12. 18 minus 12 is 6. Bring down the 3, and I'll repeat the process. 12 goes into 63 5 whole times. 5 times 12 is 60. Subtract, and I get 3. Bring down the 5, and repeat the process. 12 can only fit into 35 twice. 2 times 12 is 24. Subtract, I get 11. Because I still have a remainder, I'm going to have to add a decimal place and keep going. I don't know how many decimals I'm going to need, so I'll just add a bunch. Let me bring down this 0. And now 12 can go into 110 9 times. 9 times 12 is 108. Subtract, I get 2. I'll bring down a 0. 12 goes into 20 once. 1 times 12 is 12. If I subtract, I get 8. I'll bring down another 0. 12 can go into 80 6 times. 6 times 12 is 72. When I subtract, I get 8 again. Because I got 8 twice in a row here, I see that that pattern is just going to keep continuing. So I'm going to get an infinite number of 6s at the top here, repeating. So what I can do is just write one of those 6s and put a line above it to indicate that it's going to repeat. Let's go on to question 2. Let's do this multiplication, once again without a calculator. I'll start by multiplying 4 by 492, and then 30 by 492. 4 times 2 is 8. 4 times 9 is 36. I'll write the 6 here, carry the 3 above there. 4 times 4 is 16, add the 3 to get 19. This 3 represents 30, so I need to add a 0, and then do 3 times 2, which is 6. 3 times 9 is 27. Write the 7, carry the 2. And 3 times 4 is 12, add the 2 to get 14. I can find my product just by adding those two values. Adding the first column, I get 8. The next column, I get 12. Write the 2, carry the 1. This column, I get 17. Write the 7, carry the 1. This column adds to 6. And in this column, there's just a 1. Let me zoom out so you can see the full answers. If you were able to get those two answers, congratulations, you passed grade 5 math. Welcome to grade 6 math. To pass grade 6, you just have to know how to evaluate expressions using the correct order of operations, and you have to know how to divide fractions. Let's start with the order of operations question. To do question 1, you just have to remember BEDMAS. BEDMAS tells you to do brackets, then exponents, then multiplication and division, then addition and subtraction. So for this first question here, the first thing that we should do is evaluate inside the brackets. 7 minus 4 is 3. Next, we should evaluate the exponent, so 3 squared is 9. Now I'll do multiplications and divisions, moving from left to right. So this multiplication comes first. 4 times 5 is 20. And now I'll do 20 divided by 2, which is 10. And before I can do the addition, I have to evaluate the product of 9 times 5, which is 45. And lastly, I can add 10 and 45 to get 55. Let's move on to question 2. I need to divide those fractions. The rule for dividing fractions is we keep the first fraction the same, so 4 over 5. We change the division to multiplication, and we flip the second fraction. So it becomes 10 over 3. And when multiplying fractions, you just multiply the numerators, so 4 times 10, and multiply the denominators, 5 times 3. I'm going to make this easier by reducing right now. I've got a 10 divided by 5, that can reduce to 2 over 1. So in the numerator, I just have 4 times 2, which is 8. In the denominator, I have 1 times 3, which is 3. Let me zoom out and you can check your answers. If you were able to get 8/3 and 55, congratulations, you passed grade 6 math. Welcome to grade 7 math. To pass this grade, you're going to have to remember some angle properties and how to find the volume of three-dimensional shapes. Let's start with question 1 where it says solve for angle x, y, and z. First thing I notice is that those two lines cross, and I know angles opposite from each other are equal. So I know angle y would have to be equal to 53 degrees. The next thing I notice is that on a straight line, the angles that make up that straight line, so x and y, have to add to 180. They're supplementary angles. So I could say that x plus 53 has to be equal to 180. Let me write that little equation. And then if I solve that equation by subtracting the 53 to the other side, I get x equals 127 degrees. And now to solve for z, there's a few ways we could do it, but I noticed that on this line, all three angles that make up the line would be supplementary, meaning they add to 180. So 53 plus 18 plus z would have to equal 180. So I'll write that equation. 53 plus 18 is 71. Subtract that 71 to the other side, and I would get z is equal to 109 degrees. Let's move on to question 2, where we have to find the volume of this canopy. Let me zoom in on the canopy. Notice this canopy is made up of two shapes. There is a triangular-based prism at the top of the canopy, and there is a rectangular-based prism at the bottom of the canopy. So we need the volume of both of those shapes. It'll be important for you to remember that the volume of any prism is equal to the area of the base of the prism multiplied by the height of the prism. So if I try and apply that formula, so let me start by finding the volume of the triangular base prism at the top of the canopy. I just need to find the area of the base of that prism, so the area of that triangle. Well, the area of a triangle is just a half times the base of the triangle times the height of the triangle. So I'll do a half times 10 times 4. That gives me the area of the base of the prism, and that has to be multiplied by the height of the prism, which is 14. If I do that calculation, I get 280 feet cubed. Now I need to find the volume of the rectangular base prism that's at the bottom of the canopy. I need to start by finding the area of its base, so the area of that rectangle. I just do the length, which is 10, times the width, which is 8. And that has to be multiplied by the height of the prism, which is 14. If I do that calculation, I get 1,120 feet cubed. So the total volume of the canopy, I would just add those two volumes together. 1,120 plus 280 equals 1,400 feet cubed. Let me zoom out. If you were able to get all 4 of these answers, congratulations, you passed grade 7 math. Welcome to grade 8 math. To pass this grade, you'll have to know how to do some basic algebra and know how to use Pythagorean theorem. Let's start with question 1, where we do some basic algebra. I need to solve for what value of x makes the equation true. I'll start by getting both variable terms on the right side of the equation and both constant terms on the left side of the equation using inverse operations. So on the left, I'll have 10 minus 6. On the right, I'll have 3x plus 5x. When I collect my like terms, I've got 4 equals 8x. To isolate that x that's being multiplied by 8, I would do the inverse of multiplying by 8, which is dividing by 8. Do it to both sides. On the right, the 8's cancel, and I get x equals 4 over 8, which you would have to reduce to get a half. On to question 2 of grade 8. We have to find the height of this pyramid. So I'm looking for the length of that side. I notice that side is part of a right triangle. Let me just outline that right triangle. And I know it's a right triangle because by definition, the height is going to be perpendicular to the base of this pyramid. And the other thing I notice is that this side here is half the diagonal of the square at the base of the pyramid. Since it's a square-based pyramid, I know that what I'm outlining now is also a right angle triangle with a right angle at the corner. With the green right triangle, I could find the length of the diagonal, and then I can use half of that length as that side of my blue right triangle, and then Pythagorean theorem will allow me to solve for the height. Because I do know this side, notice it's going to be the same as 33 since this is a square-based pyramid. So let's start with the green triangle. Both of the shorter sides are 36. And I know based on Pythagorean theorem that the sum of the squares of the shorter two sides, so 36 squared plus 36 squared, is equal to the square of the longest side, which I'll call the diagonal d, so d squared. 36 squared plus 36 squared is 2592. So that's what d squared would equal. To figure out what d is equal to, I would have to move the squared over. The inverse of squaring is square rooting. So the square root of 2592 is equal to d. So this whole diagonal is the square root of 2592. I actually only want half of that. Let me make a note of that. So now using this blue right triangle, Pythagorean theorem would tell me that the square root of 2592 over 2 squared plus h squared is equal to the hypotenuse, which is 33 squared. I can simplify this term by squaring both the numerator and denominator. That would give me 2592 over 4, which is actually equal to 648, plus h squared equals 33 squared is 1089. If I subtract that 648 to the other side, 1089 minus 648 is 441. And then to isolate h, I would square root the 441. And the square root of 441 is 21. The height of that square pyramid, so the height of that square pyramid is 21 centimeters. If you were able to get that answer, and that answer. Congratulations, you passed grade 8 math. Welcome to grade 9 math. To pass this grade, you're going to have to be able to find the equation of a line perpendicular to y equals negative 3/5 x plus 7 and goes through the point 6, negative 2. And then you have to graph the line. Let me start just by quickly graphing this line. I know it has a y-intercept of 7 and a slope of negative 3/5. So I'll plot the y-intercept and then rise negative 3, so down 3, and then run 5, so to the right 5. I want the equation of the line that's perpendicular to that one and goes through the xy point 6, negative 2. So I know it's going to look something like this, so that's perpendicular. Let me find its equation and then draw it more accurately. To find the equation, I know that it's going to have a slope perpendicular to negative 3/5. So a slope that is perpendicular to negative 3/5, I do the negative reciprocal. So flip it and change the sign, so it becomes positive 5/3. I can come up with the y equals mx plus b equation by subbing in that perpendicular slope for m, and this xy point for my x and my y in my equation, and then solving for b. So I'd have negative 2 equals 5/3 times 6 plus b. This works out nicely because 6 divided by 3 is 2. So I have negative 2 equals 5 times 2, which is 10, plus b, so b is negative 12. So the equation of my line is y equals 5/3 x minus 12. To graph the line, the y-intercept doesn't fit on the graph, but I already have a point. So from that point, I'll just use my slope of 5/3. So rise 5, run 3. That means go up 5, and then right 3. And then plot a point. And there we have it. There's the graph of the line and its equation. If you're able to get those correct, congratulations, you passed grade 9 math. Welcome to grade 10 math. To pass grade 10 math, for this quadratic relationship that we see here, we have to use the x-intercepts and the vertex to sketch a graph of it. Let's start by finding the x-intercepts. I know wherever it crosses the x-axis, it's going to have a y value of 0. So I'll set y equal to 0 and then try and solve the equation. I can solve this quadratic by factoring. I would start by common factoring a 2 from all the terms. And now I can factor this using the sum and product method. I'll find numbers that multiply to the c value of 5, add to the b value of negative 6. The numbers that satisfy that product and sum are negative 1 and negative 5. So that means that quadratic in brackets can factor to x minus 1 times x minus 5. And now using the zero product rule, I know that product would be 0 if any of the factors were 0. X minus 1 would be 0 if x was 1, and x minus 5 would be 0 if x was 5. So my x-intercepts are at 1 and 5. I'll plot those on the graph. Because quadratics are symmetrical, I know that the vertex is going to be in the middle of those two x-intercepts. So the x-coordinate of the vertex, I could find that just by averaging my two x-intercepts. So just add 1 and 5, and then divide by 2. That equals 3. So I know the x-coordinate of the vertex is at 3. To find the y-coordinate of the vertex, I can just take that value of 3 and sub it in to the original equation for x, and that'll give me the y value. So the y-coordinate of the vertex would be 2 times 3 squared minus 12 times 3 plus 10, which would be equal to negative 8. My vertex is at 3, negative 8. For bonus points, I also know that the y-intercept is at the constant value, so it's at 10. Because parabolas are symmetrical, I know I could plot another point at 6, 10. If I connect those points, I have that parabola shape of that quadratic. If you're able to get the correct x-intercepts and the correct vertex of that quadratic, congratulations, you passed grade 10 math. Welcome to grade 11 math. To pass this grade, you just have to know a bit of trigonometry. You have to be able to find the exact value of sine of 225. And I should mention, no calculator for this one either. To be able to get the exact value without a calculator, you'll have to know your special triangles. The special triangle that will be needed for this question is the isosceles special triangle. The isosceles special triangle has side lengths of 1 and 1, the hypotenuse is root 2, and the acute angles are both 45 degrees. Let me start by drawing this principal angle of 225 in standard position. So I'll draw a Cartesian grid. A 225 degree angle would be in this quadrant here, which is the third quadrant, quadrant 3. The reference angle is the angle between the terminal arm and the closest x-axis, so the angle between 180 and 225 is 45. I also know the cast rule, which tells me that in the third quadrant, only tan is positive. So the sine ratio that I'm calculating in this quadrant is going to be negative. I'm trying to calculate the sine ratio of 225 degrees. I'm allowed to use the reference angle instead, as long as I consult cast rule to know that the sine ratio has to be negative. So sine of 225 is equal to the negative of sine 45. And from my special triangle, I can get the exact value of sine 45. Sine 45 means from a 45-degree reference angle, do opposite divided by hypotenuse. So sine of 45 is 1 over root 2. So sine of 225 is negative 1 over root 2. But of course, that has to be rationalized. So I need to multiply top and bottom of this by root 2. And I get my final exact value of negative root 2 over 2. If you were able to get that answer, congratulations, you passed grade 11 math. Welcome to grade 12 math. We've got a calculus local extrema question. It says find the local extrema of this f at x function. I know at any local max or min point, the slope, the derivative, is going to be equal to 0. So I'll start by finding the equation of the derivative using the power rule. So the derivative f prime of x is equal to, for each term, multiply the exponent by the coefficient and then subtract 1 from the exponent. So for the first term, 3 times 2 is 6. And the exponent goes down by 1 to 2. So I get 6x squared. Do the same thing for the other terms, and I get minus 6x minus 12 plus the derivative of any constant is 0. So I'm going to set this derivative to 0, and now I'm going to solve this equation. And I can solve it by factoring. I'll common factor out a 6. And then using sum and product factoring, I know that the numbers that have a product of negative 2 and a sum of negative 1 are negative 2 and 1. So I know that quadratic would factor to x minus 2 times x plus 1. Using the zero product rule, I know that this factor would be 0 if x was 2, and this factor would be 0 if x was negative 1. So I have two critical numbers, x equals 2 and x equals negative 1. If I sub both of those back into the original function to get the y values, I get 2, negative 15, and negative 1, 12. Those are my critical points. So I'm going to test those critical points to see if they are a local max point, a local min point, or maybe neither. I'm going to do it using the second derivative test. To do the second derivative test, I just find the second derivative. So I differentiate the first derivative. By finding the derivative of each of those terms, I get a second derivative of 12x minus 6. And then into that second derivative, I sub in both of my critical numbers to see what the sign of the second derivative is, so that I know the concavity of the original function. So f double prime of 2, if I sub in 2 into this equation, I get 18, which is positive. Because it's positive, I know that the original function must be concave up at an x value of 2. Therefore, it must be a local min point at 2, negative 15. So let me write that down. And now I'll sub in my second critical number, negative 1, into my second derivative. So f double prime at negative 1 would equal negative 18. Because that answer is negative, I know that the original function must be concave down at that point, so the point negative 1, 12 is a local max. There you go. If you were able to figure out those answers, you passed grade 12 math. Congratulations. Welcome to university level math. To pass this university level math question, you just have to be able to use integration techniques to find the area bounded between two curves. To find this shaded area, I'm going to first have to know where do these two functions intersect. So the top function, the red one, is the quadratic, so that's f at x. And the blue function is the linear function, so that's g at x. To find where they intersect, I'll set the equations equal and then solve, and I will get an x value here, which I'll call a, and an x value here, which I will call b. I can then find the definite integral of f at x minus g at x dx between a and b. So let me write down what that would look like. So let's start by finding a and b. So I'm going to set the equations equal to each other. So f at x was 2 minus x squared and g at x was x. And now I have to solve that equation. So it's a quadratic. I'll set it to 0. So 0 equals x squared plus x minus 2. That factors to x plus 2, x minus 1. So my 2 points of intersection are at x values of negative 2 and 1. So I can now write down that that a value is negative 2 and that b value is 1. So in my indefinite integral, I can start to sub in some values. I know my lower and upper bounds of integration now. My lower bound is -2. My upper bound is 1. And I know the f at x and g at x functions, so I can sub those in. So to find the value of this integral, I need to find the value of the antiderivative of this integrand at 1 minus the value of it at -2. So let's find the antiderivative of that integrand. The antiderivative of 2 is 2x minus the antiderivative of x squared is x cubed over 3 minus the antiderivative of x is x squared over 2. So now I find this value in x is 1 minus this value in x is -2. If I evaluate all of that, I get 4.5 units squared. If you were able to get that answer, you're at the university math level. Congratulations. Make sure to leave in the comments what level you got to and what series you want to see next.